so here we have an object of mass 1.5 kilograms. It's tied to the end of a string 0.5 meters long, and it's swung in a horizontal circle. Keyword, horizontal.
What does that even mean?
Means like the circle's like this, right?
No, I know. Well then.
Okay. With UCM, UCM just means that that it's rotating at a constant speed, such that it makes 5 revolutions in 4 seconds. Find A, the frequency, B, the period, C, the speed, find the centrifugal acceleration 2 different ways, and E, the tension in the string. All right.
What does frequency even mean?
Well, let's talk about that.
Frequency is.
What does frequency even mean? How frequently do you come to physics class?
Every day.
Once every day, right? Once every 24 hours. So the frequency here is how many times every something does it go all the way around. So the frequency really refers to the revs per second. When you have a sports car and you have the RPM gauge, that's revolutions per minute. So it's how fast your engine is spinning every minute, right? 5,000 RPMs. So if we're going, it makes 5 revolutions in 4 seconds. So it's going to be 5 divided by 4. The frequency is going to be 1.25. Now what do you use for a unit for frequency? I guess you could use revolutions per second.
Yes.
There is a fancy scientific word. The unit is Hz. It's hertz, yes. Hertz, yeah.
See, that hurts. I didn't know that.
Beat me to it. When you tune in your radio, right, to something megahertz, right? That's like thousands of hertz. Yeah, it's the frequency of the radio waves. When you tune in to 7:30 a.m., it's, anybody know what the AM stands for?
Something, I don't know.
You're listening to a radio frequency that has an amplitude of 730. 730 is the amplitude modulation.
What is FM?
FM is frequency modulation. So all AM waves have the same frequency, just are bigger, but FM is this, or yes, it's the frequency that differs.
So I was tweet the other day, and it was like, I'm feeling a tan coming on, and there's just be some atom that said sign overdose. And I laughed.
And then you went, oh, I'm such a nerd, eh? Yeah. Okay.
And then like all the replies are like, what does this even mean? I don't get it. I was like, hey, you should take recall.
Math losers. Okay, so the frequency is 1.25, but generally in our formulas we need the period. So what does period mean?
That's T.
T
Total.
time for 1 revolution. No, not 1 hertz, 1 revolution. If it makes 5 revolutions in 1 second, then how long does it take for 1? Well, it'd be 4.5. It would take 0.8 seconds, which is also exactly equal to, did you guys know that the period is equal to 1 over the frequency?
Oh, I
So 1 over 1.25 is 0.8. That's the best way to do it. Frequency and period are the inverses of each other. They're like Spider-Man and
Venom.
that's it.
Venom.
Yeah. The Black Spider, yeah?
All the old games are just badass.
See, nice Spider-Man suit.
Okay, so those are pretty easy. Now what about speed? How do we find speed? Well,
On this formulas.
let's look at our old friend V equals D over T. What is the displacement? What is the distance traveled when you're traveling in a circle? Circumference, which is 2 pi r divided by the time, or the period. So 2 times pi, and the radius of our string here is 0.5, and we divide by our period, which is 0.8. Here's where you need to calculate. Okay, so we got a velocity of 3.93. Now the next step is to find the acceleration, right?
It's v squared over r, I'm looking at it.
Okay, so let's do that. So Mike says, and simple acceleration is v squared. Now, a lot of kids ask me, sometimes I use little r, sometimes I use big R. I'm trying to work towards big R because my little r's are kind of hard to write. So if you see me flipping to little r, I'm not doing it on purpose. There's no real difference. Little t and big T kind of stands for period. Little t is just sort of generic time, but as far as I know, there's no big deal with little r and big R. So I've got 3.93 squared all over 0.5.
Oh, R stands for radius.
Yes, R stands for radius. What'd you think?
I got no idea.
Oh. 30.9 meters per second squared. Now that's the easy formula, but because we're cool physicist dudes,
We're gonna do 4 pi squared r.
we're going to give it a whirl, yeah. 4 pi squared r all over t squared. Oh, now I should point out, and I forgot to do this the other day, because pi r squared is so ingrained in our vocabulary, people have been learning about pi r squared circle for so long, is that when you get 4 pi squared r, is what sometimes happens is I see kids writing 4 pi r squared. Just because, right? It's not.
4 pi
It's,
squared.
it's 4 pi squared is the k value, right? So just sort of a little cautionary warning there.
Times
So 4 pi squared times 0.5, and t squared is 0.8 squared. And I get 30.8, which is almost the same thing. Now, what would be the advantage of doing it the second way here?
Wait, so that one of those is
You don't have to
forward.
find your velocity
Yeah.
for this.
Yeah. For the second one here,
I
with
did it that way.
you don't have to find the velocity. So this is more of a two-stepper. This is more of a single-stepper. But the formula is a little bit more, bigger.
No, I
It'd
mean,
be the same.
I mean like the acceleration going the same way.
I know. All right. E asks for the tension and the strength. So when I say tension,
Force. It's actually force.
it's actually, yes, it's equal to the force. Right. We're talking about force here, right? So it's Fc is equal to,
Let's use the easy one.
we can go mv squared over.
R.
In fact, could we not say that the force is equal to mass times acceleration and use this number right there?
You can try it.
Wait,
Because after all, this a right here is equal to v squared over r. Like if I put v squared over r, what am I going to end up doing? I'm going to do that again times m. Why not just go?
Let's just do it like all three ways.
Why not just go 1.5 times my 30.9? 46.2 newtons.
I don't even know what to do anymore.
Okay?
I don't even know anymore, man.
Now, if you want, you could go Fc is equal to m4 pi squared r all over t squared, but that seems like a lot of work because it's going to be just m times 30.8 over here, right? So, I mean, you've got a lot of tools at your disposal here, really.
Stuff is not bad at all.
No. It looks complicated, right? I have to tell you that the vertical circles get a little more complicated. We'll leave those for tomorrow. Because gravity, yeah, exactly.
wait, no.
Because it like overcomes gravity on the way up, and that turns into momentum on the way down. It's crazy. I don't like it.
That's not bad.
So what happens to the R? Like why did you divide by R?
Where?
Like Fc equals mv squared over R?
No, I took
That's like nothing.
this, this is equal to m times a, right? If you want it this way, then that would be 1.5 times v squared, which is 3.93 squared divided by r is 0.5. But I've already done 3.93 squared divided by 0.5. It's equal to 30.9. Like you're just repunching it in, right?
So like, yeah, so if you don't, yeah.
You're gonna get the same number, right? Okay, I'm gonna give you a few minutes. You guys try number 2. Talk amongst yourselves, try number 2. You got lots of space there. If you want, I can guarantee you that if you draw a line down the middle and do your answer on the left side of the line, there'll be plenty of room if you make a mistake for the correct answer on the right side. There's a lot of room there, so.
You know, we're gonna-
Give number 2 a try.
It's vertical circle.
Let's have a look here. A string can withstand up to 7.5 kilograms hung vertically on it and then it breaks. So what they're telling you is that you can put 7.5 kilos on it and then it breaks. So the braking force is equal to the weight force. So that's 7.5 times 9.8. So that is 73.5. String breaks when 73.5 newtons of force is placed on it, right? Okay, so that's the braking force. Find the maximum speed reached before braking. So how fast can it go? Well, it brakes, it has a centripetal force of 73.5 when it brakes. So what is the V squared just prior to that moment, kind of thing? So this is where I'm going to put my 73.5 in. The mass, now which mass do I use?
0.2.
The 2. The 7.5 is just for the braking force, right? So it's just 2 V squared, and the radius here is 4.
Good.
So V is going to be the square root of 73.5 times 4 divided by 2, which is 12.1 meters per second.
12.124.
So a 4-meter long string, and it's going 12 meters a second. It's cooking, right? It's going fast, and it's a big circle. What's the period of motion at break time?
Wait. That's it?
Yeah, that's it for part B.
Oh.
That's why I was surprised it took so long.
Well, we were all like, we found the one speed, and then Alex took off 1,000. It's like, this will be the speed when it goes
Oh,
over.
yeah, 'cause it says to find the speed before break.
Yeah, well, so when it reaches 12.1, it will break,
Oh.
right? When it gets to that 12.1, it will break. And what will be that period of motion? Yeah, you kind of overthought of it. 2 pi r all over v.
I did m4 pi squared r.
The radius is 4. You could do that. I get
2.07. Better get that one.
2.08 seconds.
Oh, my goodness.
2 seconds to go all the way around, but it's cooking. I don't know. I just wrote it down. I got 2.08.
Well, you're wrong.
Could be. I've been wrong before, but that was 1970.
2.267.
Pretty easy question, right?
You're wrong about B2. Oh.
Alrighty.